probably chew right through the battery doing this, but whatever. It is what it is. All right, so I'm going to start off reviewing piecewise functions, and then we'll get into, just want to make sure my pen's going to work after all that. Piecewise functions, absolute value functions, then we get into limits. All right. We start off with the skill-based stuff with sprinkling in the theoretical, but before too long we move generally to the theoretical. All right, so we'll do some practical instances, but we will do a few proofs along the way just to kind of get across the ideas in a more general sense rather than in a particular case. All right, so just a quick review of domain in interval notation. All right, so you have interval notation, you have inequality notation. Generally speaking, you kind of need to be prepared for both. Right, so it's not so much that, it's not a pre-calc class, so I'm not going to assess you on your ability to write in interval notation or inequality notation. It's more so that you can interpret what you see in those various notations. All right, so the first problem here, I don't know why it says do now. It's just an example. All right, state the domain in interval notation and determine any asymptotes for the function. All right, so the types of asymptotes that we could be looking at would be vertical asymptote, horizontal asymptote, or oblique slant asymptotes. But before we do that, we'll take care of the domain. All right, so looking at this function, really, whenever you're addressing domain, we look for two things. When we're dealing with non-transcendental functions, so algebraic functions, we look for two things. We look for a radical. We look for a denominator containing a variable. All right, so if there is no radical, obviously you don't have to worry about that. But if you have a fraction with a variable in the denominator, you have to account for that by addressing it in the form of an excluded value. All right, so for my domain, I'll just make a note here. I'm going to take the denominator, set it equal to 0. All right, and solve. We're really not doing anything monumental there. So we're basically excluding 0. All right, let me pull up the calculator. I'll just move this over here. I'm going to have to kind of do it this way. It's a little annoying, but I'm going to go with wrong class, because I haven't explained anything yet, so it can't be my instruction. So in the TI calculator, you have different shortcut keys that you could use. If you're not really familiar, definitely pay careful attention when I go over this stuff. I'll try to write down the steps for the more complicated things, but something like putting a fraction into your calculator, you could do it with parentheses and division if you want, but you could also do alpha y equals, bring up this little shortcut menu. All right. If you have one of the older TI-84s, as I'm looking around, I don't really see too many of like the ancient ones. So we should be all right. This shortcut technique should work. That being said, there is some subtle differences between the backlit rechargeable calculator that has the color screen and the not backlit color screen calculators. Right? So yeah, basically that bad boy. So it might look a little different, but the hotkeys should still work the same way. All right, so I'm going to select that option, and it allows me to put a fraction in, x squared. So pull up the x, power of 2. All right, this xt theta n key, for those who don't have a ton of experience with the calculator, that brings up an x if you're in function mode, a t if you're in parametric mode, a theta if you're in polar mode, and n if you're in sequence mode. All right, so depending on the mode your calculator's in, it'll bring up a different variable. All right, -1, down arrow, pop in an x, So I have my function popped in there. This shouldn't apply to you because I use this for stats also. You see I have highlighted above here, I have plot one. That's a statistical plot. If you have anything highlighted in that top row, you want to turn it off because it could interfere. Because what will happen is if you have it bolded like I do here, if there's no data plugged in, then the calculator is going to try to make a statistical graph, find no data in a list, and throw an error. All right, so we're going to just hit enter to kill that. And then we could do a zoom 6 if you want to get started, or you can manually adjust a window. I leave it up to you. You'll find that you're going to have to at some point manipulate the window depending on the nature of the function. So I'll address that in more detail as we go. But zoom 6 is zoom standard. Not really sure why it's not zoom 1. Like, it should be the first thing that we do. Sorry. I'm an elbow flailer kind of person, so that might happen sometimes. So you could hit the number 6, or you could just toggle down to 6 and hit enter. All right, and here you can see there's a break in the graph. That break seems to happen at x equals 0. All right, so it's pretty consistent with what we just determined in terms of the domain. I can go into the window. I'm sorry, the table. So by hitting second graph, I can go into the table. And the good thing about using the fraction tool to put your function in, it'll give you fractional, wherever possible, it'll give you fractional answers or fractional values for y when you go into the table. If I did it as parentheses x squared minus 1 divided by x, I didn't use the fraction tool, it would put all these values in as decimals. You may want it one way as opposed to the other. It's all a matter of preference. But if I scroll down here, when I get to 0, I see an error. So oftentimes you could pick out excluded values from your domain by just going in the table and having a look. The problem is if the x value for which there's a break in the graph is not a clean number, so if it's a funky decimal or an irrational number, then it won't show up in the table. Right? So what I usually do is have a look at the picture, see if I notice anything that stands out. Then I go to the table, have a look. That's assuming I don't want to do it algebraically. Right? In this case, it's pretty easy to pick out that it's x not equal to 0. But they did say that we're doing this in interval notation. The interval notation involves the parentheses and the brackets. All right? So parentheses exclude the endpoint. Brackets include the endpoint. All right. I'll move the calculator in a second, sorry. That might end up being an ongoing sort of thing. All right, so if I want to state the domain excluding the x value of 0, I'll draw the number line. You don't have to draw the number line. I'm just doing it for instructional purposes. All right, so if I do a number line, just talking about all the possible values for x, anything going on down to negative infinity and anything going up to infinity, but at 0, you have an excluded value. So with the number line, we represent that with an open circle. So we're looking at a function that spans the continuum but excludes 0. All right, so what we would need to do is that just in interval notation. All right, so what we're saying here is that we're starting at negative infinity. We're going to go up to 0, but we're not actually going to make contact with 0 because there's nothing there. All right, so we're going to go from negative infinity to 0, but I'm going to pop a parenthesis around that 0, saying that we're getting really, really close to the 0, but we're not actually getting there. All right, a common question that I get right? Maybe not in this level, but you never know. If you haven't seen this in a while, you may not really be thinking it through. Some people will say, well, can I go up to -1 and put a bracket on it? Like, isn't that the same thing? Well, no, because you have infinitely many values between -1 and 0 that you would be kind of lopping off. So we need those values too. Well, we don't know that we need them, but we need to have the opportunity to have them just in case. Right? You never know what we're using this for. So, this is just a skill, a calculation, a computational skill. But if this is used for a greater purpose, maybe you do care about those decimal values between 0 and 1. Right? So we're also going to put parenthesis on the negative infinity. And that's more of a theoretical component because you can't actually get there. Right? So how can you include something if it's always on the move? It's like you're reaching out for it. If you can grab it, you could put a bracket on it. But if it's always just out of your reach, you could never bracket it in. You could never grab it and bring it into the set. All right? So we put parenthesis on that also. All right? Same idea on the other end. We're starting at 0. We're going to infinity. Parentheses all around. And then we are allowing for the fact that it could be in the first set or in the second set. All right? The mathematical or allows for it to be in both potentially, but since it is a function, generally once you use an x, you're not going to use it again. Right? So we use a union here. Union is the symbol for a mathematical symbol for or. Right? All right. So when you would solve a quadratic and you get x equals 2, x equals -2, it wasn't x equals 2 and x equals -2, although in your mind you might say, my answers are x equals 2 and also x equals -2. But you can't have a number that's 2 and -2 at the same time. So when you get into the logic of it, we would say that it's 2 or -2. Either 2 or -2 will satisfy this equation. You're not going to plug them both in at the same time. So you plug in one. When you're done with that, you plug in the other. Right? So that's an instance of or. Right? So this is how we would state the domain in interval notation. It's much simpler the other way.
Do we need the D, or if I would have just done the brackets and the U?
You don't need the D. Yeah. You need some way of distinguishing, because if a question says to also find the range, then you would want to distinguish one from the other. However you label it is fine. D, R, domain, range. We also have to determine any asymptotes that might exist. So I'm looking at first the vertical asymptote. All right. A vertical asymptote, just to review, is kind of a lot going on there. The most common practice for finding a vertical asymptote is just set the denominator equal to 0 and then solve. And whatever you get as a result is going to be most likely a vertical asymptote. Right? The twist on that is if there's a point discontinuity in the function or a hole in the equation, or I'm sorry, hole in the graph of the equation, then you might think that it's a vertical asymptote when it really isn't. So there's a few different ways to get around that. What I do generally is I look for a common factor, top and bottom. All right, look for a common factor, top and bottom. Numerator, denominator, but like less syllables, less characters to write, so I'm just going to say top and bottom. All right. If there is a common factor, you factor it out. All right. Little run-on sentence here for you. And factor out, then cancel. Right. Also apologize for my handwriting. It's actually a whole lot nicer on this app than it would look on paper. It's like one of those things like a spinal condition. So every now and then I just flat out lose all feeling in my right arm, which kind of sucks. But also just generally the precision of writing, it's not there. But fortunately the app smooths it out, but it's not perfect. All right. So look for a common factor top and bottom, and then factor out, then cancel. All right. Then set your denominator equal to 0. So set bottom equal to 0. And solve. All right. So I used all this space to write how to do it, and I left no space to actually do it. But fortunately, there is no common factor top and bottom, right? Because if I factor out the top, I could. I'm not going to, because I know that even though that top is factorable, one of the factors is not x, right? In order for that to be the case, each term in the numerator would have to have an x in it, right? That's not the case here, right? So I can kind of skip right past that. So then I set the bottom equal to 0 and solve, right? So set the bottom equal to 0, x equals 0. That's my vertical asymptote. All right. It's not always the case that the excluded values match up precisely with your vertical asymptotes, but it happens fairly frequently. All right. The exception would be is if there's a common factor top and bottom that you can cancel out. All right? If you can do that, then what you canceled out is the location of a point discontinuity in the graph, or a hole in the graph. All right. Horizontal asymptote. Here there's really more notes, I guess, in this little review. Horizontal asymptotes. And again, just going back for a sec, vertical asymptotes, horizontal asymptotes, oblique asymptotes, these are things that you should have seen before and worked with fairly frequently in pre-calc. That being said, it doesn't always stick. All right. I remember when I was a student, I know that I learned about horizontal asymptotes in pre-calc, and then when I'm sitting in a calc class, I'm thinking to myself, I'm like, oh, there were rules for that. I don't remember any of them, but I know there are rules for that. So fortunately, what's that?
I think the vertical asymptotes are easier to figure out.
Yeah, because it's not.
It's more intuitive.
Yeah, it's intuitive and it's also procedural. You could just solve.
It also just like thinking about it just makes sense. I mean,
Right.
like obviously it's not going to work if it's numerator equals the denominator equals 0.
Right. Yeah, exactly. So like as long as you have an understanding of undefined functions, then you really it's only a matter of time before you just kind of figure it out. The horizontal asymptotes, there's two ways to go about doing it. Actually, 3. I'm sure more than 3, but 3 that I use. One would be the 3 rules by which you can determine if there's a horizontal asymptote. Another is a graphical approach based off general understanding of what an asymptote is. And then the last is to use a limit, but that's kind of like a circular logic thing. Like we could use a limit, but we haven't learned about limits. So we'll do it the other 2 ways. Then we'll learn about limits, and then we'll circle back and see how we could have used limits to find horizontal asymptotes. All right. So the rules.
I'm glad to hear that. I thought that limits were part of pre-calc. So.
They are,
Okay.
but it's at the tail end of the course.
So I'm glad we're going to do that.
Yeah. So for the horizontal asymptote rules to work, you need to know what the degree of the numerator is and the degree of the denominator. Most textbooks call those values m and n for no reason that I can think of, except that they're consecutive in the alphabet, I guess. So degree of, I'm going to say top, is equal to m. Degree of bottom is equal to n. All right. You can call it whatever you want. You can call it n and d if you want. Just something that makes sense to you. But all the rules that I'm about to write relate to the characters m and n, so we're just going to do it that way. So if m is greater than n, there's none. If m is less than n, then it's specifically the line y equals 0. If m is equal to n, it's the ratio of leading coefficients. All right. So if my m value, so the power on the top, the highest power, that's what the degree represents. The degree of any polynomial is the highest power contained within the polynomial. So in a rational function, which is what we have here, you have polynomial up top, polynomial on the bottom. Whatever the high power is, that's your degree. All right. So in this case, m is greater than n. Yeah, because m is equal to 2, n is equal to 1. Therefore, m is greater than n, and there's no horizontal asymptote. All right. So that's information. You know, like it's not good or bad. It's, you know, if there's no horizontal asymptote, there still could be a slant asymptote or an oblique is what they call it. There is a conflict there, right? So if you have a horizontal asymptote, then you will not have a slanted asymptote. If you have a slant asymptote, you won't have a horizontal, right? The specific case for the oblique or slant asymptote, depending on the book or the resource, they go either way with it. So I'll just say, I'll just land on OA for oblique. If m is equal to n plus 1, then the oblique so the numerator's degree has to be exactly 1 more than the denominator's degree, which is what we have here because this is a power of 1. All right, so that relationship is tailor-made for the oblique asymptote. Oh, what? Where am I? There we are. All right. Then the oblique is the quotient of the top and bottom excluding any remainder. And this is kind of a I don't love the oblique asymptote topic as in terms of where it's placed in the curriculum. They want us to introduce it early on, but the true understanding of why this makes sense only comes after we talk about limits. All right, so we just kind of have to bide our time on that. All right, so there's 2 ways that you could actually physically divide the numerator and denominator. If it's a monomial on the bottom, which is what we have here, we could just split the fraction up and simplify. If there's a polynomial on the bottom, then you would have to use either long division or synthetic division, right? And we'll review those as we go forward. Synthetic division is you know, like the quicker and easier one, but long division sometimes gives you the right look, you know, like in terms of what you're looking to get as an output. So it's a couple more steps early on, but your final, I'll call it product, but you know, not as in multiplication, but like what is produced, will look more like what you want it to look like. All right. So in this case, though, I'm like stealing all the room here. Let me just kind of chuck it in down here. I'm going to say y equals x squared minus 1 over x. All right. Now this is a subtle change in notation. So we generally work under the belief that y is f of x, right? But It's more like we're making that statement. Y is not always equal to a function of x, right? But what I'm trying to do here is distinguish what I'm going to get as a result here, which will not be the original function f of x. After I make my modifications, it's going to be a new equation, all right? And that new equation may not be a function. In this case, it will be, but this is just a way of distinguishing my oblique asymptote from my function f of x, all right? So here I'm just going to do y equals x squared over x minus 1 over x. So we get y equals x minus 1 over x. In that simplification process, you end up with the sum or difference of a polynomial function, in this case it's linear, and a rational function in simplest form. That rational function in simplest form, that is the remainder. All right, so that's my remainder, so we're going to drop that. Right? And again, that's what I was saying before. Like the explanation is going to come after we talk about limits, so you got to kind of table it. If you do have experience with limits, I can tell you that when you're finding an oblique asymptote, you're finding the limit as x approaches infinity of that function. And when you put infinity in the denominator of a fraction, that fraction goes to 0.
Right.
So if you have any basis of understanding limits, then that should make sense. If not, then sit tight. A couple classes down the line, we'll have the answer to that. All right, but the short answer is that this gets tossed, and we're looking at y equals x. That's my oblique asymptote. All right, so what I'm going to do, I'm going to bring the calculator back in, and I am going to graph these things. All right, so I have my vertical asymptote. Now, one thing that I absolutely despise about this calculator, it doesn't handle implicitly defined functions, or explicit in terms of x. I'm sorry, solve for x. So it's always in the form of y equals, so I can't graph a vertical line. So, but I can draw a vertical line, but graphing it is not something this calculator can handle. Pretty much every other calculator can. Could do it using parametrics, but that's more of a Calc 2 thing, right? So I can graph y equals x. And the good thing about this calculator is that it'll distinguish between the two, the original function and my asymptote, because one's blue and one's red. Now, if you have the older version of the calculator, you should have a little slashy thing. I just call it that, right? Even though it doesn't have the color coding, there should be a slashy thing here. And if you hit enter on it, you can go, well, it's not going to look the same on this, but if you hit enter on it, the first thing that happens is it goes from skinny to bolded, so you can distinguish between the two that way. All right, so let me do that. Create the graph, and you can see, well, maybe not. I don't know. It's kind of tough, but we have the blue curve that seems to be, as we go from left to right, it seems to be increasing without bound, without restriction here, right? The calculator doesn't have the common courtesy to put arrows on the end to indicate that this is going on forever, but it is, all right? So if you're following along this curve, you're following the path, you go up, you get to positive infinity, and then I'll just say at this point, until we really get into the why of it all, that you're going to be magically transported to negative infinity to continue your trip, all right? And as you go out towards negative infinity in terms of x, blue is merging with red, all right? And that's the idea behind an asymptote. It's a line, or at least for our purposes, a line that you get closer and closer to without ever touching, right? For the extreme values, I'll call it the exception, is for a horizontal asymptote. There could be many intersections in the short run, but as it gets out to the most extreme form, it'll get closer and closer, but never actually make contact. All right. So that's happening here for the slant asymptote as we go left, as we go right, but it's also happening in the middle as we go up and as we go down. All right, so it's a justification for a vertical asymptote, which was easier to pick out. The horizontal asymptote didn't exist. The oblique asymptote is that red line. All right. So I think that puts a ribbon on this one question. Yeah, I probably should at some point edit this document to give probably a lot more space for that first example. All right, anyway, more on that later. So a piecewise function, I put a little comment in there, graphed basically in pieces. Right? So we're looking at two components, in this first example, two components that make up the graph of f of x. All right? And the value of something like this has to do with the fact that, I mean, if you're modeling kind of a real world situation, depending on the nature of whatever it is, you might have different functions to represent different things, right? So tax brackets work that way, but it's just horizontal lines, a bunch of pieced together horizontal lines to make up your function, right? But I also look at it like a rate of growth. So depending on what it is, whatever it is you're talking about, it could be population growth. I used, it's probably not, I mean, it's definitely not current anymore, but I used the Thanos snap from Infinity War to explain piecewise functions at one point, because you have the population growth growing, right? It's growing, growing, growing. And then snap, half the population is gone, but they're still going to grow. Right? So you have two different functions that would represent the population growth, but it's still related to the same thing, so it's still technically part of the same function. All right? So two exponential functions that are pieced together to model whatever the situation is. All right? You really could do that for a lot of things. I mean, any historical event of any kind of significance that might impact whatever it is you're working on, that could. I mean, it's a little bit more morbid, but like the whole baby boomer, like the World War II, like population decrease, population increase. It's two functions that you piece together to make up the population of Americans, definitely, but human race. So that's the value of a piecewise function. The TI calculator does not handle these very well. They technically have kind of a workaround that allows you to create a piecewise, but I'll just say that the process is so convoluted that you're probably not going to want to do it. I'll show it to you anyway, because you can at least see. And I know depending on whether you have the older version or the newer version, there's definitely a disparity there, right? So we'll do it by hand first. Graph each part of the function separately. So I look at it just like I did here with the oblique, is I'll look at it like two separate equations, y equals 2x squared and y equals 2 minus x. All right, you could use a table approach if you want. You could also, just, I call it graphing and erasing. You graph the function and just get rid of all the stuff that you don't want, right? Because I'm restricted here in that I'm starting off with 0. Oh, actually, this is something that I meant to fix. It doesn't really impact anything, but these two should be swapped. So it really should be. We tend
Start
with
from the left and go right.
exactly. We tend to work negative infinity to infinity. All right, so that's what it should be. I mean, I guess we'll just do it. It really doesn't matter in terms of like how we're going to do it, but I'll just swap them up here.
Wait, so just work that way, or you mean like the x is greater than, more than or, sorry, equal to or greater than 0 should be for the 2 minus x? Is that what you mean?
No, no.
Well, I guess I could have made the problem like that too, but it's really just the domain x greater than 0
Oh, yeah,
equals
start
0.
off with that side.
Yeah. All right, so we'll do this if x is less than 0 and if x is greater than or equal to 0. I guess this is as good a time as any to talk about it. What I do for bonus in this course, well, actually most of my courses, I give bonus points for finding typos in the packets, any packets that I give you, and I already pointed out like 2 of them here. It's on a first come, first served basis, because I've had it before where, and this is why there's, I mean, I've been teaching for 25 years, and I still have like packets that are riddled with typos, because even though I started offering bonus for it, what'll happen is at the end of the course, I'll have like 20 people submitting the same 3 typos. So I don't like that. I prefer to have it as like you find a unique one. If you're the first one to get it, you get some bonus. You get 1 point for each typo you find, up to 3 points per unit. All right, there's 3 units in the course, so you can get 9 bonus points. So it's not terrible. And don't worry. I mean, I'm not going to say there are infinitely many typos in these packets, but there's a lot. Right? And so,
Look out.
yeah. So little things like, I mean, I made a change here. Do now became example. And honestly, not that you care, because you're getting points, but the reason I do this is because I find these typos in class, I point them out, and I completely forget to change them for the next semester. Right? So the email helps me do it, because then I'll get into my packets and I'll make the adjustment, and I give you the credit. Right? So here's one, spacing. I mean, if I had to steal space from a second question in order to finish the first one, then I did not give you enough space to do it. All right, so anything like that where it's like not enough space for the first example, but way too much space for the third example, things like that. Those are typos. So you send me an email. All right, so you send.
Missing line at the end of the graph.
Yeah.
At the bottom.
Yeah, anything that would help my notes be improved. Like, this is an opportunity for you to nitpick. All right. In terms of punctuation, I mean, I'm pretty inconsistent. Like, sometimes I'll use a colon, sometimes I'll underline, sometimes I'll use boldface, italicize.
Major in English.
Yeah,
That's not your job.
This is true. This is true. So, yeah, and I'm a fly by the seat of my pants user of a comma. Like, I don't really give much thought as to when that should be used, that form of punctuation. So I just go by gut feeling. Like, as I'm typing, I'm like, I feel like I'm due for a comma. I haven't used one in a while. Just pop that bad boy in there and go.
That's semicolons.
Semicolon. Like, oh, this feels right.
Or
We'll
the
get that in there.
word perchance or however.
Yeah. However, thus.
No, this is not.
Oh, what was the other one? Yeah, therefore.
Therefore, chance.
Hence, that's the one.
Hence,
Yeah.
therefore. Hence thereof.
Yeah.
There's too many thus.
Yeah. So all that stuff is bonus opportunity. So yeah, I ask you to email me because I can reply with a thumbs up or nothing at all. So if you send the email and you get a thumbs up reply, that means I put it in my grade book that you have bonus, right, for that. So the thumbs up is like you got it, right? If you don't get a reply, just because what'll happen is I'm going to get about 20 emails saying you have to change do now to example. I can't reply to the other 19 people. Right? It just takes too long. So if you get the thumbs up, you got the bonus. If you didn't get a thumbs up, you didn't. All right, so you just kind of wait for your next opportunity. And I've never had an instance or an issue with students being like, "There's just no more typos. Like, how am I supposed to get credit?" I'm like, "Listen, like, they're there. Sometimes I fix a typo and I accidentally make a new one. Like, it's just a never-ending thing, right?" So anyway, I figured I'd bring that up before you're like, "Wow, this guy makes a lot of mistakes in his packets." Like, yeah, I do, but I give you credit for it.
Teacher does.
Exactly.
Like everyone.
Everyone, and I'm the thing I'm guilty, probably most guilty of, is like my brain is working one step ahead of where I am in solving a problem. So I'll write down, like if I'm supposed to write like 2 plus 3, I'll write 2 plus 5. Because like I'm thinking of the 5 because that's what the 2 plus 3 is, and I'll accidentally write that down and I have no explanation for it. So there's some inexplicable things that are going to happen this semester. So anyway, y equals 2 minus x, but specifically only for the values that are less than 0. All right. So what I could do is I can make a table, and I can cap that table off at 0, just kind of making a mental note that I'm not actually going to include the 0 in the set. So I'd do a few values, whatever it takes to get it. I mean, for if it were parabolic like the next one, you want to make sure that you always have, if the vertex is in the domain, you want to make sure that you have that plotted on your graph. All right. But for a line, I mean, you draw a line, all you need are 2 points and a straight edge, or a steady hand, which I don't have. So I'm going to cap this off at 0, but I'm going to make a little note here that we're going to go open circle at 0. All right. Now there is no restriction on the low end. All right. So I could do a few values, -1, -2, -3, -4, and so on. All right. So I can keep going, and so on. That means that I'm going to throw an arrow on this end. All right. I'm going to pop in the -4, -3, -2, -1, so on. You could also do it on the graph if you pick out the slope and the y-intercept, but you could also just do direct substitution. 2 minus -4, 2 plus 4 is 6. 2 minus -3, 5. And once you get the trend, because it's linear, you just follow that trend until you use up all the x values. So 4, 3, and 2. Okay. And you could plot, but I don't know about you, but I find that whenever I tackle like an unfamiliar problem graphically, now these I've done for years, so like I already know things like scaling, like I have it in mind. But when I tackle a new problem, I always find that I jump the gun on plotting points, and then find out that I needed to scale the graph. And it was like, all right, well, let me throw that out and start all over again because I needed to go by 5s instead of by 1s. So recommendation is have a look at all the coordinates first before you start plotting. Even if it's just doing it in the calculator, just take that extra time to do it just to make sure that you don't end up having to redo a graph. Right?
At least it's not like the x and y axis are on different scales. That's the worst.
That's the worst. And also, like when we get trig and exponential functions involved.
Oh yeah.
Yeah, for an exponential, it's like, oh yeah, I could go like -5 to 5, but when you're like at 5, you're at like 300 billion.
Yeah.
And you're like, okay, I probably should have went more than 20 on the vertical axis, you know. So here I'm going to start off at 0, 1, 2. I can go as far as I want. Go as far as you need to go in order to get an idea about the graph. 2x squared has a vertex at the origin, so that first x value is going to be the vertex. So I don't really need to go out too far, but you know I can if I want. Closed circle, or I can if I'm able, depending on the amount of space that I have. Closed circle, because we're including the 0, and we have no upper restriction. Right? There's no upper bound for this. We can go on to infinity, so whenever that happens, we throw an arrow. All right, so 0 is going to give you a 0, 1 is going to give you a 2, 2 is going to give you an 8, 3 is going to give you 18, and 32. Yeah, 1, 4, 9, 16, double it up, we're good. So yeah, I don't need to go this high. I don't even think I can go this high unless I scale the vertical axis. And depending on the nature of the problem, you may choose to scale it. But if you can get a reasonable representation of what the graph ought to look like just by plotting a couple of points, then that's fine.
By the way, never mind, I completely lost my question. I lost my drink.
Happens all the time, mostly to me.
Yeah. Or I won't.
Yeah, it's usually when you don't have the opportunity to ask it anymore. Like you're on your way home, you're like, that's what I wanted to ask. So let's see. I only have 1, 2, 3, 4, 5 boxes to play with here. I don't know that that's enough, so I'm going to go by 2s on the vertical axis. So 2. That should be enough. Honestly, when it comes to scaling, I don't really care too much about like the labeling, as long as it gets the idea across. So what a lot of people will do, and this is perfectly fine from where I'm sitting, like just label the first one. So if you label the first one and say you're going by 2s there, then it's understood that you're going to continue to use that relationship, right? You could also do it like this. You could say by 2s. I think this is simpler. But what a lot of people will do is they'll label it all the way up the line just because they don't want to have to count boxes. There's like, okay, when I go to graph like 10, how many boxes am I going up? I got to count by 2s every time. It's like, depending on how intricate the graph is, that might be a big deal or not. If you don't label, I assume that you're going by 1s, right? So -4, 6. Let me, I'll keep it blue. -3, 5. In this case, because I'm going by 2s, feel free to not label the odds or plot the odds, because it's going to be a straight edge anyway. -2, 4, and then 0, 2 with an open circle. So we shoot it on out here, throw an arrow on it. Then we have 0, 0, 1, 2, 2, 8. And that's really as far as we can go.
We get the idea.
But you get the idea, exactly. So throw an arrow on here and you're good. Just never, every teacher has their nitpicks. And mine is plotting points outside of the grid. So don't plot points outside of the grid. Right? Just, line fine, yeah. But don't plot a point and be like, oh, this is about 18 up here. Like, no, just don't do that. All right.
IB makes you do that sometimes. Like, they'll say, like, plot it from this exact range to this exact range.
And it doesn't fit on the grid that they scaled?
Give you a grid that is already, like, lined by 1s, and it's a 5x5 grid, and the number is like 10. And if you don't extend the grid and do it with a pencil,
then it doesn't fit.
then they give you a full 0.
So they're
I took calc. It was really dumb.
wait, they're telling you that you do need to do like
Like, you
I
need
gotta
to-
go.
Yeah.
Is that supposed to show that you're thinking outside of the box and that you're innovative?
Or whatever.
Yeah.
Basically,
It's just IB.
IB
It's
is
terrible.
Yeah.
Terrible.
Yeah, because like I would probably,
Physics is-
I would definitely have words with a student who does that. Yeah,
At
it
least
could,
the IB final was like, IB final isn't gonna try to trick you, unlike the Regents, which,
right.
I mean, I got like,
I feel like the AP exams look to trick you probably more than,
oh
yeah, like straightforward questions. I mean, if it's a skill-based problem, then there's no need to
should be
dress it up.
skill-based.
Yeah,
they shouldn't be that tricky.
yeah, it's brutal. I don't like that kind of stuff. I mean, there is a time and place for that, but it's really more in the advanced levels. Like when a person's just trying to get to learn the skills to go out of your way to trick them is kind of dumb. Let me show you really quickly. I mean, like really quickly. how to do this on the calculator because I'm prefacing this by saying that it's not pretty. So the odds that you're going to want to do it this way, regardless of how careful I am with explaining it, is very minimal. And that being said, I'll probably screw it up anyway, so we'll see. So y equals, you put in your two pieces separately. 2 minus x, and then x, 2x squared. 2x power 2. All right, now if I were to just go ahead and graph this, I'm going to get the entire line and the entire parabola, which is not piecewise. All right, so let me show you that to show you what will not get you any credit on a test. All right, if I ask you to graph a piecewise function, now this will be with the context of a limit. So you're going to have to use your piecewise graph to find limits. So the better of a job you do on your piecewise graph, the easier it's going to be to find the limits. This is not a piecewise. This is just two separate functions. All right. So don't put this on paper.
Is there any way to tell the calculator what the...
That's the weird part. All right. So, and I'm pretty sure it's parentheses, but if it's not, I'm going to find that out in a second and make the adjustment. It's either parentheses or squiggly brackets. I can never remember because I hardly ever do it this way. Open paren, put in your domain x less than 0. All right, so x. Then you got to go into the test menu. All right, this is a Boolean operator deal. All right, so I go into second math, and that's where you get all your logic stuff. All right, so I want the less than. Oops, overshot the Mac. You can scroll down, or you can just hit the number 5. Either way,
It is not parentheses.
it's not parentheses, so we're going squiggly bracket.
That would make sense, because
Yeah, because parentheses could be a product. Yeah.
Yeah.
you're using a squiggly to kind
It just draws a straight
of
line.
the piecewise function also.
Right.
At the intersection of the y-axis, it just draws a straight line with that.
Uh-oh.
That's the other thing. Yeah. Oh. Yeah. This is a no-go.
We love it.
Yeah, so x greater than or equal to 0. So like all these keystrokes to get there, and it doesn't even do the thing the right way.
If you're good at ignoring things, then it doesn't.
That's what I was going to say, is that when you do this and then you plot it, as long as you're like, okay, anything that's a horizontal line, just disregard, unless, of course, it's supposed to be a horizontal line. If a piece of your piecewise function is constant, doesn't have a variable,
I think, yeah, you'll
then
know that.
then you should be able to pick up on that pretty quickly. But I'm just looking at this as like, even if these numbers were more complicated, I could still go into the table and grab the stuff that I need. All right, so if I go into the table, even in its original form, and it puts zeros in there for that, like there's really no meaningful, nothing valuable in that. Let me get rid of this stuff. If you're going to do it with the calculator, my recommendation is you put the functions in. Don't look at the picture, because I've already addressed what will happen. That's not going to be good. So you go into the table and just line your table up for the relevant values. So like the first one is going to be capped off at 0. So I would just line my table so that the very last number there is the x value of 0, and just pull anything that I think is useful out of this list. And then the other one is going to start at 0. So I'm just going to kind of ignore that y2 column until I plot the y1 column. And then I'll toggle my list so I'm only looking at the relevant values for y2. Right? Some people go the extra step of turning off 1 and then turning it on. So if you do that, you're just hitting enter on the equal sign. That's something you should probably get comfortable with anyway, because when you're working multiple functions at a time, sometimes you just, like if a window applies for one but not the other, and it just took you a few minutes to type it in because it's a complicated function, you don't want to delete it, but you don't want to see it on the graph either. So for that, you just hit enter.
Yeah.
Yeah.
Once that thing is turned off, it won't graph anything.
It won't graph it, and it won't give you the coordinates. So that's kind of nice. Question?
So for that function, or at least for the piecewise function, you have to use the actual
It's in there now? Let's see.
Should say like paste.
Ah, they did a little update. Okay. So how does that work?
Mine
Did you get 3 points on the unit?
It definitely should get something for it, yeah.
Yeah, if you put it, you have to put it into a place where you can actually.
do you have to like put it on catalog? It's
Yeah,
probably
but you can put
catalog.
it there. So if you clear that out, and then you just.
And then do this, comma that?
It's like a
Yeah,
matrix.
you have to clear
Makes like a
it.
matrix. And
You have to clear
Yeah,
it
you
out.
gotta go
and
to
then
matrix?
Yeah,
when you put
that's
it
what I
in,
figured.
It'll ask you like how many.
basically.
Oh, I see. Okay.
You put
That's
it
so
in,
fire.
you should put it in, you know.
Right. So, oh, I see what you're saying. So get rid of this.
I guess. I feel like it's harder to do that.
Well, let's see the. I mean, if the look of it is right.
Yeah.
You had to do math IA too, didn't you?
Huh?
Math IA?
Yeah, I did mine on some really stupid thing. You just have to,
I just-
it was just
Oh, so
stats.
they use
Yeah,
a
you
semicolon to
basi-
say when.
Right.
Yeah.
So that's their if. Okay. I think I forgot to put the X in, but I'll get that in there real quick.
I had like calculus, so I was just like, okay, we're gonna do like measuring antiderivatives and we're gonna measure a rocket equation. And it didn't work, but he was nice because he didn't want to do a research paper from that, so he just gave me 100
On the
on the
Oh god, what happened to my cat?
Doesn't the IA get graded by other IB teachers?
I have no idea. I got 100 for my grade.
What school did you go to? What school did you go to?
High school did you go to?
Dobbs.
Oh, Dobbs. Okay.
is the other one I watched.
Yeah, that's the other one.
Because I know Greenberg does it too. Woodlands. My friend teaches there.
See if that works, right?
Okay, moment of truth.
I had a.
Oh, thank you.
That's beautiful.
Beautiful.
I put in my
Teach me
function.
what I gotta do.
Yeah, you know, like I mean, in terms of the I mean, it's not giving you the open and closed circles, but at least it gives you the shape. It gives you a good idea of, you know, domain windows and things like that. So, yeah,
Math, piecewise.
math right on down to piecewise, and then if
Go up instead of down. It'll bring you to the bottom.
Bring it
Yeah, I
up.
don't have that.
say it
I
again.
don't have that either.
You press math and then you just press B.
Do you have it?
Math option B.
Yeah, I don't have that. Yeah, my.
Oh, that's the other thing. Yeah.
So they were updated.
They update these calculators, or they update the operating system. So if you have an older operating system, you'll have to do an update.
Yeah.
I could do it.
You plug it into what
Yeah,
else
they
you
have
need?
a.
Yeah, there's the
firmware
USB
updater
port.
on their website and download it onto your computer and then plug it into the like special USB thing. And then
You know what I can do is
Yeah.
what I'll do is because I have all these different kinds of calculators. I'll download the operating system, make sure that it works on the older versions, and then I'll bring a wire and I'll dump it in for anybody who needs it. Because it's cool. It's nice.
firmware's free.
Yeah, I started. I think I mentioned this last time. I've kind of moved away from the TI calculators, and I use NumWorks now. But I mentioned here because your Calc 2 teacher is going to be expecting you to know how to use the TI. So I'm back to this. But if there are any other updates that you know about for the betterment of all, it's definitely worth sharing. One thing I do know how to do. Let me just do a quick. So graphing an absolute value function. We're actually going to, before too long, learn how to find or write equations of absolute value functions as piecewise functions. Right? Because when it comes to finding limits and derivatives, it's more useful to have it in piecewise form. Right? So that's something coming down the
When
line.
you're trying to find the area under a graph, you need to take the whole equation anyway because
Right.
I was doing that for my and asked me how I used it. I'm still angry about
Yeah.
that.
The credit's not transferred?
Yeah,
No, not at all.
Which is really stupid.
That makes it even worse.
They don't-
I
they
did
didn't take
so
the
much
IB
more work
credits.
than the Regents class, and I basically did not just calculus but calculus 2
Right.
They
in
don't take
class,
it.
and they don't count them at all
Yeah. The same thing for physics, because I got a 7 on the physics exam for IB, and they didn't take the credit at all. Not even for any of the
That's
physics.
that's brutal.
Yeah.
I know, like College Board
I
is
was like,
like why do they do this? Why didn't I
take
do
the
AP? Yeah.
class?
Yeah, so alpha window, or you could go into the math menu. Most of the things that you need, regardless of whether it's calculus or probability statistics, like you find a lot of stuff that you need in the math menu. But the shortcut keys, I always have a look. If I'm not sure, I'll just jump into one of these, alpha y equals alpha window zoom and so on. And odds are I'm going to find the thing I'm looking for. So here it's the absolute value, brings up the brackets. Should have put the 2 in first. I did not, so I just insert that, pop in the x, minus 3.
Isn't that like a rule where it's like if the variable, if there's only like one variable and it's like completely encased and it's the only thing in the absolute value, you can just
Plus or minus.
plus or minus.
Yep.
That's what
So I'll lock that in. I'll do a zoom 6. Actually, I could just hit graph because I didn't change the window, but just force a habit, zoom 6. And then you have that V-shaped curve. Again, it's along the lines of piecewise. Depending on the nature of the function, you might find it to be more troublesome to do it in a calculator than to just do it by hand. The general form, standard form for a absolute value function, f of x is equal to a times x minus h plus k, where h and k, h comma k is the vertex. If a is positive, then you have a V-shaped curve. If a is negative, you still have a V-shaped curve, but it's the reflection. And a represents the slope, right? It's just a question of which direction you're going at. Damn it. Poop. Sorry. That's going to be an ongoing issue. That's one thing I'm probably going to need help with as we go forward. It's like I'm writing up a storm, and I have a calculator blocking what I'm writing. So if that ever ends up being the case, just
That's where they
just
like,
let me know.
They
You know.
tell you like to teach math
And then also learn about all this technology to make it possible to teach math.
So absolute value functions will never have like an exponential curve in them. It's
You
always gonna be-
you can have absolute value functions, so composite functions with exponentials. You could have it with parabolas.
if there's multiple x's and
Oh, it would have to be outside the absolute value.
Yeah.
Okay,
Right.
got it. If the variable is inside the absolute value, then it will be always boxy.
Yeah, as long as it's just
well,
a this.
it could be horizontally shifted. So like if there's
No, I don't mean
minus
with the
one-
origin of 0, I just mean shape.
Okay. Yeah.
Right, yeah. So the A value is 2. HK is going to be 0, -3. Not everybody needs the extra detail that I'm about to show you, but if you do, then you know it's worth it. So I could rewrite this just to get the HK. I could rewrite it as f of x equals 2 times absolute x minus 0 minus 3, and just match that up with the standard form. Because most of the time, I mean, this happens with the standard form for a parabola also, where people will be like, well, how did you know it was negative instead of positive? It was a plus sign inside the bracket, but you made it negative. And it doesn't always click. So I like to show this approach. So these two things should be equal. and these two things should be equal. So you could actually manually solve. So we would say negative 0 is negative h, which means h is equal to 0. And we'd say negative 3 is equal to k, which means, well, k is negative 3. So you can get these values using that technique, but if you just see it, you don't have to show the work, right? I try not to overemphasize algebraic processes because some of us are capable of doing this stuff, even the more advanced stuff in our heads, and I don't want you to have to write it down for me. You write it down if you need to write it down, but like simple algebra, like you don't need to show me how you factored, just factor, all right? And even something as simple as like finding a vertical asymptote, if you see it right away, there's no need to write like x minus 1 equals 0 or x squared minus 1 equals 0, x plus 1, x minus 1 equals, you could just say plus or minus 1 is your vertical asymptote, right? So you can cut out as much of that fluff as you want, right?
Only you show me understand.
Yeah, the calculus stuff I'm going to want you to be more precise with, but the algebraic stuff, not so much. All right, so at 0, negative 3, I'm plotting a point. The a value is positive, so I know it's v-shaped, it's an upward v, with a slope of 2, so up 2 over 1, up 2 over 1, both ways. All right, that looks awful. Let me fix that. Yeah, I think there's something wrong with the scaling on this this graph grid also. And it's a little out of whack. Just do it like that. Right. I'll take that as a typo. I mean, these graphs, they just, something happened in the PDF process that knocked them out of whack, so I'll have to put them in as images, I think. Right. Now, let me see if it makes sense here. For absolute value functions, one of the ways I like to do it is really more of a visual approach. Let me just show you something real quick, because we're only focusing on the linear cases here. But let's say you had the absolute value of, I'll just throw an x squared in there. All right, so instead of a linear, I have a power of 2. All right, and go to the graph. In some cases, so this one, it's, I'll say obvious maybe, but maybe you don't find it that way, I don't know. But if you look at the function that's in the absolute value, you can kind of look at it as sort of, I'll call it overkill, right?
You don't need the absolute value.
You don't need it
Same as x squared.
because when you raise an expression to an even power, it's automatically positive, right? So that's something that you can kind of, like, if you see something like absolute value of x to the 4th, or like whatever, and you know, well, that's always positive anyway, then you strip away the absolute value and just work with the function itself. Then you have, let's say you have, I'll do minus 4 here. Oops, a little double tap there. So then you have that, right? Let me graph that in comparison to x squared minus 4. All right. So when you see something like that, you can kind of cut out a lot of the procedure by knowing what it's supposed to look like. All right. So let me turn off the parabola. What we're looking at here is an instance where the part of the parabola that was negative was reflected into the positive continuum
The absolute value.
because of the absolute value. right? So when you're dealing with, I mean, absolute values, we always know is like, all right, you're taking whatever the number is and you're stripping away any negative, right? Why would that be any different graphically? You know, so it's really the same idea. It's just a question of what happens to the negative part, right? So what happens here is that it gets reflected over the x-axis. And that'll be true, and you'll see this as we go forward because, you know, like we'll work on some transcendentals, some funkier functions. This one is not, I wouldn't categorize it as funky. Oh, why did I do that? I wouldn't categorize it as funky, but I mean, it's not linear. If you're familiar with the structure of a sine function, then yeah. Like you're just taking all the negative parts and flipping them up over the x-axis, right? So it makes it a whole lot easier to handle these kind of problems.
Distance versus total distance trend.
Right, yeah, all that stuff. Yeah, because when you get like net areas versus total areas, yeah, it could be a little dicey. Right, so little tricks like that could be helpful. The next couple of pages, there's a bunch of problems, but I figured I would just take you through like maybe one or two more. I always kind of overdo it with like the amount of problems that I put in the past. Like anything that we skip over, you could use as practice. And the answer key posted on Brightspace has the solutions to everything. So you could work through it, and if you have any questions, we can go from there. But I wanted to go through one that had 3 pieces to it, and also a constant. So number 6 on page 5. I don't know where I got 8 from there. All right, so a quicker way of doing it could be just considering what the line would look like. I called it graph and erase. You know, so depending on what instrument you're working with, if you're working with a erasable something or other, that's fine. For me, it's really easy because I just wipe it out very quickly. But if I'm looking at y equals x negative x minus 1, so I'm at negative 1 with a slope of negative 1. So I'm looking at something like this, you know, plot these points, and then I say, oh, but wait a minute, I want to be less than 0. So I get rid of all the stuff that's not less than 0, add 0. I would pop in an open circle because I can't get to 0. Not with that piece anyway. And then draw a line. And that's that first piece. So like I didn't go to a calculator and make a table of values. I just kept it simple. The thing that throws people off very frequently, and it's really so simple that it shouldn't throw you off, but it does. It happens, right? The second piece here is that y is 5 when x is 0, which is definition of an ordered pair. This is really just saying 0, 5. Okay. That tends to throw people off from time to time. Right. Then the last piece, x plus 2, but only in instances where x is greater than 0. So then I would say, all right, well, I got my y-intercept. It's going to be at 2, but I don't want the x value to be 0, so I'll put an open circle there, and then I'll just count off my slope. Because the coefficients were relatively simple, I could pretty much leave it that way. All right. So, you know, they can be fairly easy to handle, piecewise functions. And then, you know, if you want to check it with the calculator, you get a little extra time, you want to make sure that you approached it the right way, then you have that ability now. I think I mentioned last time that it's around this time that I'll end class, right, on any given lecture day. just because I always want to give a little time at the end for people who might have individual questions. So I'll stop the recording.